everyone. Today we're talking about OEE calculations for food manufacturing, and this is part of our process engineering course at Niagara College. And we are delving into the topic of DMAIC and Six Sigma systems. And so we need to have different measurements in our manufacturing system to be able to tell how effectively we are operating. OEE just happens to be one of the more common ones, and we'll delve into what that looks like right now. So at the end of this video, you will be able to understand the quality measures used for OEE, or what is otherwise known as overall equipment effectiveness. We'll perform some basic OEE calculations for food manufacturing, and we'll discuss the dynamic impacts of OEE in food manufacturing systems. And we'll delve into some topics of root cause analysis, and that may be a video that you follow up with because we are going to be delving into the different tools of quality measurement. And this just happens to be one of those overarching ones. And my cat says, oh, he wants to talk to you too, don't you? You want to learn how to run a food factory, don't you? He just might, because I think I'm going to be doing a new case study, and pet food just happens to be part of the NAICS code for food manufacturing. So oftentimes when you're working in different food establishments, you might see in the quality manager's office or as part of some of these quality scoreboards, you'll see these OEE scores. And today we're going to just walk through and figure out what the heck they are. Now, the main thing, and I want to stress this, is that in each establishment, they may be using slightly different nuances, and that should be established in their standard operating procedure. How are they going about making those measurements? And if you are going about making any changements, that those are documented within the standard operating procedures for the establishment. But main thing is each of the parameters that defines the OEE is something that's a measurement done within the establishment. And let's figure out what those measurements are based off of some of the typical measurements that are out there. So in general, there is a calculation that is A times P times Q equals OEE. And what does that mean? It means availability times performance times quality equals your overall equipment effectiveness. And we'll parse out what each of these letters means. But the main thing that I want to say as our take home is that we keep seeing this repeat sequence where we have actual divided by optimal. That's really the pattern that we're going to see for each of this. So actual availability versus the optimal availability, actual performance versus the optimal performance, actual quality versus optimal quality. And when we multiply that together, it makes this score that we can track on a daily basis, or you can, within your operating procedure, in your documented operating procedure, you can define what that time frame is going to be, and then you can start to observe variation within that. What is normal variation? That common cause variation that we spoke about before versus what is special cause, or the sorts of variation where you notice that things are getting out of whack, such that you need to go in and do root cause analysis. I like this calculation because it gives you a little bit more scope for which you can do your root cause analysis. So let's dig into each of these. So A is for availability, and that is again that runtime divided by planned production time. And that runtime is defined by, so what is the available time in your typical production minus the time that your equipment gets stopped. Now, I brought up this line and it says, is food safety activity stop time? Well, oftentimes in establishments, they'll say, oh, you know what? Food safety activity where you have to stop lines for sanitation, that's stop time. Well, is it stop time? It's a little bit conflicted in that food safety activity, food safety and quality teams should be working in close partnership. In some establishments, they are not. In other establishments, they are the exact same team. This is important to establish within your operating procedure, that if it's a food safety activity, it shouldn't be penalized as part of your planned production time. Food safety activity is not a loss of productivity, it's an improvement of quality. So let's jump out and talk about performance. Performance is where you're looking at your ideal cycle time versus your actual cycle time. And so there are a number of different equations that are commonly thrown out there, but ideally it's where you're saying, hey, this is how much we actually produced in our period of time that we had available to us versus what would be optimal. And I'm going to show some calculations in just a minute, walking through some numbers, but This performance value is often thrown off by the manufacturer of the equipment itself, where they'll say, you know what, we can make 1,000 units in an hour on this machine. Well, oftentimes equipment manufacturers exaggerate what they're capable of doing. You need to be able to justify that as a quality manager and go in and say, we've never had it run that fast. Sometimes you might need to set your optimal performance, that denominator, the bottom of the fraction, at a slightly different point. That's going to strongly impact versus the actual. That actual performance is determined by a lot of different factors. How well trained were the people working with that piece of equipment? How smoothly is that piece of equipment working? Performance is strongly linked to quality in that sometimes you can run a machine or a piece of equipment at its fastest speed, but it's going to start causing quality damage to your product. And so you may be running it at slower than optimal performance because it's actually going to throw your quality parameter into a higher zone. And so these are important dynamics that you as a quality manager may need to go and justify. And again, I'm going to do some examples in just a moment. Quality equals good count divided by total count. This was the easiest of all. And this is where you need to think about how many good products did we put out as compared to the total amount of product that we produced. And it's important to delineate what is normal yield loss versus what's actual scrap, stuff that was made but had to be thrown out. And rework is an important factor in here too, in that it's important to make sure that if you are reworking and successfully reworking that product in, that that's not counted as scrap, but it's actually counted as good count. But it's something that, again, you within your operating procedure need to establish exactly how you're going to be measuring it. And if you're making any changes, that these are going to be reflected in your operating procedure. And then if that is changing your OEE score, that that's documented that a change was made in how the measurements were made. So let's go about and actually do some examples here. So I imagined an 8-hour shift, but I gave them some time to start up their equipment and I gave them some time to shut down at the end of the day. So I called it a 7.5-hour day, which is 450 minutes. I gave them two 15-minute breaks. So that would be 450 minus 30. And then we're down to minus another 30 here. So our total time that we have available for working is actually not through 450 minutes, it's 390 or 390, pardon me. That's a zero. I can't erase in the middle of my presentation and I can't figure out how to hotkey erase button. So bear with me. That is a zero. Now I've lost my mouse. So that is our total time. We need to think about what time is available to us. Now, I've seen it where in certain establishments they'll say, hey, wait a second, rather than having these breaks, we're going to run our equipment without a stop because we're losing productivity time when we're stopping. And instead we'll have our coffee breaks and meal breaks on rotating shifts where people take their lunch break or their coffee break at different times. And maybe 1/3 of the plant goes off at a different time so that equipment doesn't go down during that break time. There are ways of like sometimes those changeover times and that startup and stop time is lost productivity time. Again, I don't want to sound like I'm nickel and diming on time, but this is really important. And these OEE scores are they're a very common measure in a lot of manufacturing systems. So downtime on equipment, that's where the equipment is actually down, not functioning, not working. These are often picked up on master batch records where you'll say, here was the stop time, here was the stop time. And oftentimes there will be on a master batch record or production record notes for comment where you can state equipment was down at 9:35 for 10 minutes for, I don't know, fixing the labeling machine or something like that. These are the sorts of things that you might have to be in certain facilities. You might have to be using induction to figure out where the downtime was occurring. And in other cases, it may be on an automated sensor. Some of these dashboards, pardon me, some of these dashboards are integrated into programmable logic controllers and SCADA controllers for the plant themselves. And I have a different video about SCADA and PLC. Um, Standard production rate, that's where you have set an optimal production rate. It could be on the entire production run, or it could be on separate pieces of equipment. Oftentimes, you'll have an overall OEE score and a per unit operation OEE score. Um, and that would be overlaid to your production flowchart and the unit operations within the plant. Of course, you've got your total output and you've got your scrap. And scrap is important, that when you've got people taking product off the line that cannot be saleable, that they're not just throwing that in the garbage without measuring it. You want to have someone on measuring it, whether it's units, whether it's weight. That's different than yield loss. It's scrap. But you want to know where is product that should have been good being lost. And so measuring that in whatever units you're measuring your product in. So let's do an example. So our availability is our runtime divided by our planned production time. So as I did before, our actual production time was 390 minutes. When we took out those breaks where we shut down the equipment for that period of time, that 30 minutes here and 30 minutes there, that was minus 60 minutes, giving us 390, minus 35 on our downtime. So that's going to give us 355 divided by 390. And that equaled 0.910. We're going to carry that number forward for our overall OEE score. But this number individually is important because, again, we can think about where are we losing that production time. Where do we lose downtime? Oftentimes it's when we don't have good work in place buffers, work in place, or WIP. If you, let's say, for example, ran out of labels on a labeling machine and you needed to send an expediter out to get some labels, you could be in downtime. If your equipment had not been maintained properly. So work in place buffers, preventative maintenance. If you're not doing appropriate preventive maintenance and your equipment actually breaks down, that could be part of it. Not having pre-op inspection that sees problems within the equipment is part of that, where you could, with good pre-op, you can see that problems are starting to occur and you can accelerate your preventative maintenance. So that was our OEE score for availability. Let's do an example for performance. So again, there's lots of different equations out there. I like to use performance equals actual output versus theoretical output. So in this case, we had on our actual output, we had our actual output was 4,150. And our standard production rate, if we had 15, so this would be our optimal theoretical output. So 15 items per minute times 390, that would be, my calculator is blocked by my administrator. Fantastic administration. So I don't have a calculator. You can do the math. 15 times 390. What we are getting out is a pretty lousy score here. I've actually left my phone in the other room, so I can't even do the manual calculation in my calculator. But again, what modifies performance? Well, performance could be again, are we using the optimum production rate from the manufacturer, or are we using an optimum production rate based off of our own optimum production? Optimum is relative. Main thing, you know the rule. However you are measuring it and how are you defining the, in this case, the denominator of the equation is really up to you at the establishment. And so if you know that it's not ever going to be realistic that you're ever running 15 items per minute, you may need to go in and justify that to your general manager or to headquarters to say, this is not realistic, therefore this value is unrealistically low. Optimum's also that optimum production rate is also often linked to quality, in that if you're doing things too fast, you're more likely to make mistakes. And so the second quotient, or not the second one, the third quotient in the equation is the quality quotient. You go too fast and your quality quotient could decline. And so this one is often done in parallel with that quality quotient when doing those balancing and optimization. So you go too fast and your quality declines. Where's my pen? Another piece of the puzzle is how do things slow down? Well, oftentimes in food manufacturing, you're using temporary workers. It's not uncommon for temp agencies to provide workers for different operations, and these temp workers may not be trained to the optimum speed. And so defining what that optimum speed is really important, but also providing proper and adequate training to make sure that the different workers who are being brought onto the line are given the information to do the job properly. It's also going to impact on that quality quotient as well. They're less likely to make mistakes and less likely to cause scrap or cause those compounding errors where a mistake carries forward to the next unit operation and compounds in terms of the quality and in terms of the errors within that production. What we're doing by brainstorming after the fact is we are actually doing a root cause analysis, and I will encourage you to take a look at those toolkits for root cause analysis. Last but not least, quality. This is where we're looking at your good count divided by your total count. So how many products did you actually put out the door versus how many did you anticipate making? And again, make sure that within your operating procedure, you are not mixing up yield loss. You are not mixing up product that's lost for quality control measurements, but that you're actually measuring scrap that did not get out there because of mistakes within the manufacturing. And so in this case, we've got my hypothetical imaginary numbers are showing excellent quality, but again, what could cause scrap? Again, it could be poor preventative maintenance on the equipment, PM. It could be training on your workers. It could be proper equipment assembly. It could be quality ingredients. It could be all sorts of different factors. The main thing is we're starting that brainstorming process of thinking through all of these different parameters that could be causing quality loss. Now we take all those numbers and we multiply them together. And the thing is, a low score on one gets amplified even greater as we add them together. Why I like this equation is that we can go back to each of the individual parameters and do more strategic brainstorming on how we're losing quality and losing OEE in our process. This is the sort of brainstorming that you as a quality professional may be asked to do, to go in and figure out where is the loss of operations effectiveness and how do we fix this. You very well will be called on to do this, and that's a really critical skill set. To not just go in and point out the problems, but also go in and say, hey, here we've got some solutions. And here are some of the different strategies that we could try as part of a DMAIC process to improve the quality of that system. So there are other equations out there. Some plants use simplified OEE scoring. Main thing, you know the rule, always follow the operating procedure within your establishment and follow the same procedure. And if you are making any changes to your procedures, make sure you are documenting them in your operating procedure and documenting it in your records. Now, what's great about these scores is that you can track them over time and you can see when things are in control and you can see when things are out of control, as we've talked about. Common cause versus special cause variation. And one of the tools that we will be talking about shortly is the tool called Schuhart charts, or what we also may be calling X bar R charts. These are statistical process control charts, and we can see when our OEE scores are tracking and the variation that we're seeing is normal versus when that variation is something that's indicating we are losing control and needing a much broader intervention from our part. this is part of that Six Sigma and to make process that we've been talking about in some of our other videos. So I was joking with the students earlier because I just gave this in class on a video lecture, and I told them, why did nobody tell me that my screen share was not on for the entire hour that I was talking at them? Um, I told them, you're going to be very interesting as quality managers if you are not able to call out a mistake that you see right in front of your face. In this case, we just as a quick summary on this, some key ways that companies increase or focus on increasing their OEE scores. At a certain point, there's a theoretical limit that you're going to hit, and you really can't squeeze out any more productivity. You can't get better than 100% productivity, and it is tricky where companies will want to manipulate the numbers to make their OEE scores look inflated. You as a quality manager have to have integrity. You've got to walk out there and say, we are going to follow the operating procedure consistently and not be manipulating the numbers in a way that somehow inflates it. But instead, we're going to be able to justify those numbers with real information and with a real sense of this is why it's working and why it's not. So, how do they try and squeeze more percentage points out? One way, they'll use rotating breaks instead of full stops, because every time you stop and start equipment, there's a slowdown and a lag in that turnover. And so that's one way. Using sanitation as a continuous function versus a stop function. I realize that that's tricky, but depending on the types of unit operations that you're working on, there may be ways that you can stop or start it. Using effective breakdown sanitation and preventive maintenance. So oftentimes I've seen this happen many times in plants where the sanitation crew will break down the equipment, but they'll not reassemble it properly because they haven't been trained in the preventative maintenance. And so they might be missing gaskets or seals or lubricants that make the equipment run properly. And so making sure that sanitation and PM crews are working in concert so that equipment gets assembled properly and is not causing stops in the equipment and not causing quality defects in the product. Effective pre-op inspection by trained personnel. So that pre-op is not just a sanitation and hygiene requirement for food safety, but pre-op is also a chance for well-trained operators to see that the equipment isn't showing signs of wear and tear that may cause a preventive maintenance issue. So having the proper training on those people is really critical, not just to look for gross contamination, but to look for things like frays and belts or lubricants or chips or rust or stuff like that. Those are the signs of the need for preventative maintenance. Having a really good quality program with integrated quality control points, not just quality as an end function and measuring on the end product, but can you measure quality at all sorts of different points so that you are not amplifying errors in the system, but instead you're having the chance to rework product early so that you're less likely to lose product and lose on that P value in the OEE score. Last but not least, workplace training, making sure that people know how to do the tasks and are doing them effectively so that they're not adding mistakes and they're working efficiently and effectively. All of these add up to really effective OEE scores. And these are, again, our very common quality measures in different quality management programs. And be prepared as a new quality professional that you may be collecting the data and you may be analyzing the data as part of your job. Awesome. So I think that's the end of my slideshow. You know where to find me, and I always love your questions. And it's really fun going on this learning journey with you. And remember, if you see a mistake, always call it out. And so all of you students in my process engineering course, here's your video because I still love you guys and I do want you to learn. And next time, call me out when I don't have my screen share button on. All right. Take care, and we'll talk to you all soon.